What if I told you that beneath the surface of our seemingly stable planet lies a chaotic and violent power that has the potential to reshape entire continents? Welcome to the world of volcanoes, where the Earth's molten heart can erupt into a catastrophic force, altering the very fabric of human civilization. Every year, thousands of volcanoes erupt around the globe, but only a handful possess the latent power to cause global devastation. Among them are the supervolcanoes, titans of destruction that threaten not just local communities, but also the entire planetary ecosystem. For centuries, these geological giants have been a source of awe and fear. The ash that spews forth can blanket cities, trigger climate changes, and potentially endanger all forms of life. Imagine the impact of an eruption so powerful it blackens the sky for months, disrupting food supplies, collapsing economies, and causing massive casualties. These scenarios aren't mere fiction, they are rooted in reality. The 1815 eruption of Mount Tambora in Indonesia, for instance, led to what is often referred to as the year without a summer. The eruption released a staggering amount of ash into the atmosphere, resulting in global temperature drops and widespread crop failures. In the United States and Europe, the effects were devastating, leading to famine and unrest. As scientists and researchers delve deeper into the mechanisms of these supervolcanoes, we must ask ourselves, are we prepared for the next cataclysm? The answer may lie in understanding the complex systems that drive volcanic activity. Using the latest technology, researchers monitor seismic activity, ground deformation, and gas emissions, attempting to unlock the secrets of these geological marvels. But predicting eruptions is fraught with challenges. Even the most sophisticated models cannot guarantee accurate forecasts. History has shown that volcanoes can be unpredictable, erupting suddenly and without warning. The potential for devastation raises an urgent question: how can we safeguard civilization from the fury of these natural giants? The nature of volcanic eruptions is both fascinating and terrifying. As we will explore in the chapters ahead, understanding their power is not just about studying geology, it's about preparing for the future. What lies ahead could be more than just scientific inquiry, it could be a matter of survival. As we delve deeper, we'll uncover the stories of the volcanoes that have shaped our planet and the ominous signs that could indicate another world-altering eruption is on the horizon. To understand the potential threat posed by volcanoes, we must look back in time. History has borne witness to some of the most catastrophic eruptions, each leaving indelible marks on civilization. From the ash-filled skies of ancient Rome to the fertile but perilous slopes of Vesuvius, these events shaped societies and influenced cultures. The eruption of Mount Vesuvius in 79 AD serves as a stark reminder of this violent power. When it erupted, it blanketed the cities of Pompeii and Herculaneum in lethal ash, preserving them for centuries. Thousands lost their lives in a matter of hours, suffocated by pyroclastic flows that raced down the mountain at speeds of up to 700 kilometers per hour. Yet, the most striking aspect is how this event highlighted the vulnerabilities of society. Would modern-day cities fare any better against the wrath of such a volcano? Fast forward to the 20th century, and we encounter the eruption of Mount St. Helens in 1980, which serves as a chilling example of modern civilization's encounter with volcanic power. The eruption was preceded by a series of earthquakes and eruptions that scientists monitored, yet the actual explosion was devastating nonetheless. The consequences were felt far beyond the immediate vicinity, affecting air quality and climate across the U.S. This serves as a crucial reminder that while we may have advanced our scientific understanding, nature still holds the upper hand. These historical examples teach us valuable lessons. They remind us that we are part of a larger system, often at the mercy of forces we do not completely understand. In researching these events, scientists have noted patterns in eruption cycles. For instance, supervolcanoes often erupt on a timescale of hundreds of thousands of years, but when they do, the results can be catastrophic. Consider the Toba supervolcano in Indonesia. Around 74,000 years ago, its eruption is believed to have caused a volcanic winter, drastically reducing human population and biodiversity. The dramatic cooling effect lasted for years, leading to the extinction of several species and forcing early humans to adapt or perish. This cataclysmic event holds significance as it directly correlates with evidence of a genetic bottleneck in modern human history. As we examine these historical accounts, it becomes glaringly apparent that our world is built on a precarious foundation. The memories of these volcanic catastrophes are etched into the stone of history, and we must heed their lessons. As we move forward, the urgency to understand and mitigate the effects of future eruptions becomes paramount. How can we learn from the past to prepare for the imminent threats that loom on our horizon? What causes a volcano to erupt? This simple question is layered with complexity and has intrigued scientists for centuries. To unravel this mystery, we must delve into geology and the science behind volcanic activity. At the core of this inquiry lies magma, a molten rock that resides beneath the Earth's surface. As magma rises, it encounters various strata of rock, which can either trap it or allow it to escape. The buildup of pressure is akin to shaking a soda can. Once the lid is popped, the gas escapes violently. This principle explains why some volcanoes erupt gently, while others unleash cataclysmic fury. The viscosity of the magma also plays a significant role in determining the type of eruption. For example, thick, sticky magma can trap gases, leading to explosive eruptions, whereas liquid, runny magma allows gases to escape more gently. Geologists categorize volcanoes into different types based on their eruption style and physical characteristics. Shield volcanoes, like Mauna Loa in Hawaii, are gentle giants, formed by the flow of low-viscosity lava. In contrast, stratovolcanoes, such as Mount Fuji, are steeper and often erupt violently. Understanding these distinctions is crucial, as the type of volcano directly correlates with the risk it poses to nearby populations. Furthermore, scientists utilize various monitoring techniques to gain insight into volcanic behavior. Seismographs track earthquakes that often precede eruptions, while GPS technology measures ground deformation. Gas emissions are another critical indicator. Sulfur dioxide levels can reveal the composition of magma and its potential for an explosive eruption. Despite advancements in monitoring, predicting eruptions remains an elusive goal. For instance, the 2010 eruption of Eyjafjallajökull in Iceland took the world by surprise. While scientists had noted increased seismic activity, they did not foresee the extensive travel disruptions it would cause. The cloud of ash spread across Europe, leading to the cancellation of over 100,000 flights. This incident illustrates that even with our best efforts, volcanic forecasting is fraught with uncertainties. As we continue to explore this scientific realm, it's evident that understanding volcanic systems requires ongoing research. Climate change, human activity, and geological events are interconnected, making the study of volcanoes all the more critical. In our next chapter, we will examine the threats posed by the world's most infamous supervolcanoes and how we might prepare for their inevitable eruptions. As we delve deeper into the world of volcanoes, we arrive at the giants, supervolcanoes. These colossal formations are capable of producing the most catastrophic eruptions known to mankind. The term supervolcano refers to a volcano that has erupted with a magnitude of 8 on the Volcano Explosivity Index, which measures eruption size. To put this in perspective, such eruptions can eject over 1,000 cubic kilometers of material into the atmosphere. One of the most notable supervolcanoes is the Yellowstone caldera in the United States. Tucked beneath the surface lies a magma chamber that has erupted multiple times over the last 2.1 million years. The last major eruption occurred approximately 640,000 years ago, creating the vast caldera we see today. If Yellowstone were to erupt again, the consequences would be dire, not just for the surrounding area, but potentially for the entire planet. Models suggest that an eruption could release ash clouds that travel thousands of miles, affecting air quality and climate globally. Studies estimate that ash fallout could cover much of North America and disrupt agriculture for years. The economic ramifications would be staggering, with agricultural losses leading to food shortages and social unrest. Another infamous supervolcano is the Campi Flegrei in Italy, which lies just outside of Naples. Known as the Phlegrean Fields, this area has a history of explosive eruptions. The last significant eruption occurred around 40,000 years ago, and there are signs that it could be awakening once more. Scientists have detected unusual geological activity, including ground deformation and increased seismicity. These signs could indicate a future eruption, possibly leading to widespread devastation. The threat posed by these supervolcanoes has prompted scientists to advocate for increased monitoring and preparedness measures. Countries like Italy and the United States are investing in research to better understand the dynamics of these systems. Yet, the question remains, are we doing enough to prepare for what could be civilization's greatest threat? As we move ahead, we'll uncover solutions and strategies to mitigate the impact of these geological giants. The consequences of a supervolcanic eruption extend far beyond the immediate vicinity. They are truly global in scale. When examining the potential fallout, we must consider the chain reactions that an eruption can trigger. For instance, the ash and gases released can lead to what is known as volcanic winter. This phenomenon occurs when particles and sulfur dioxide enter the stratosphere and reflect sunlight, causing significant drops in global temperatures. History provides us with alarming evidence of this effect. The 1815 eruption of Mount Tambora not only caused local devastation but led to a global cooling event that severely impacted agriculture worldwide. Crops failed, and famines ensued, leading to unrest in various parts of the globe. The eruption's impact was felt as far away as the United States and Europe, where summer temperatures plummeted, and the year without a summer became a stark reality. Similarly, the eruption of the Toba supervolcano may have contributed to a dramatic reduction in human populations and biodiversity. This phenomenon, where entire ecosystems are disrupted, underscores the interconnectedness of our planet's systems. How can societies prepare for such scenarios? The answer lies in understanding the risks and implementing effective strategies to mitigate them. Experts suggest that early warning systems, comprehensive evacuation plans, and robust infrastructure are essential in minimizing damage and loss of life. Moreover, fostering a culture of preparedness within communities is vital. We must educate ourselves and future generations about the potential threats and effective responses. This knowledge can empower individuals to take action and safer steps in the event of a volcanic crisis. International collaboration is also paramount. Countries must share research, resources, and data to create more effective monitoring systems. Through global partnerships, we can enhance our understanding of volcanic behavior and develop better predictive models. The threat posed by supervolcanoes is not confined to one nation, it has the potential to affect us all. As we conclude this first half of our exploration, the question looms large: are we prepared for the next supervolcanic eruption? The evidence is clear: we must take action, collaborate, and invest in research to mitigate the impending threat. As we turn the page to the next chapters, we will explore innovative technologies and strategies that hold promise for safeguarding our civilization against the fiery giants of the Earth. In recent years, our understanding of volcanoes has expanded tremendously, yet the threats they pose remain a real concern. With our growing populations and expanding cities, many people now live in the shadow of volcanoes, especially in regions like Indonesia, Italy, and the Pacific Northwest. But what happens when a volcanic eruption disrupts our modern way of life? Let's turn our attention to Mount Sinabung in Indonesia. After being dormant for centuries, it erupted violently in 2013, displacing thousands of residents and blanketing the surrounding areas in ash. The Indonesian government had been monitoring the volcano, but the rapid onset of eruptions caught many by surprise. This situation is not unique. Numerous volcanoes around the world are actively monitored, resembling ticking time bombs. The data from the Global Volcanism Program indicates that more than 1,500 volcanoes are potentially active around the globe. With approximately 800 million people living in close proximity to these volcanoes, the risk of an eruption impacting daily lives is significant. But it's not only the eruptions that pose a threat, it's also the potential for lahar flows, ash fall, and toxicity that could devastate entire communities. Consider the story of the 1980 eruption of Mount St. Helens in Washington state. That catastrophic event resulted in the death of 57 people and caused over $1 billion in damage. What's more alarming is that the U.S. Geological Survey warns that the Cascadia subduction zone could produce a megathrust earthquake and subsequent volcanic activity, putting millions at risk in the Pacific Northwest. As scientists continue to study the patterns of volcanoes, they have developed sophisticated models that predict potential eruptions. However, predicting the exact timing and nature of volcanic activity remains a challenge. This unpredictability introduces a layer of anxiety among those living near volatile volcanoes. Take the case of the Campi Flegrei caldera near Naples, Italy, which has the potential to erupt with catastrophic consequences. The caldera has been active for thousands of years, and while it hasn't erupted since 1538, the ground has been lifting, indicating potential volcanic activity. The Italian authorities are aware of the danger and have instituted monitoring systems, but if an eruption were to occur today, the densely populated surrounding areas would be in jeopardy. So, what measures can be taken to mitigate these risks? Disaster preparedness is essential. Governments must invest in early warning systems and create evacuation plans for areas at high risk. Education also plays a crucial role. Communities need to be aware of the risks and prepared for the worst-case scenarios. As we look towards the future, it becomes increasingly clear that understanding and preparing for modern-day volcanic threats is not just important, it's vital for the survival of civilizations living near these fiery giants. But with our ever-growing reliance on technology, could we face a failure in our preparations? Stay tuned for our next chapter as we explore the historical lessons of past eruptions and how they can guide our future preparedness. History is a powerful teacher, especially when it comes to the destructive capabilities of volcanoes. From the eruption of Vesuvius in AD 79, which buried the cities of Pompeii and Herculaneum, to the more recent eruption of Mount Pinatubo in 1991, we've learned hard lessons about preparedness, response, and resilience in the face of volcanic disasters. The destruction of Pompeii is perhaps the most famous volcanic event in history. When Vesuvius erupted, it released a cloud of stones, ashes, and fumes to a height of 33 kilometers, spewing molten rock to a distance of up to 12 kilometers. This event claimed thousands of lives and buried the city under approximately 6 meters of volcanic ash. Archaeologists have uncovered a snapshot of Roman life frozen in time, but the tragic loss of life serves as a stark reminder of the potential consequences of volcanic eruptions. Fast forward to the 20th century, on June 15, 1991, Mount Pinatubo in the Philippines erupted in one of the largest volcanic eruptions of the century. The eruption expelled ash and sulfur dioxide into the atmosphere, affecting global temperatures and resulting in significant climatic changes. This eruption provided valuable data for scientists studying volcanic impacts on climate, demonstrating the profound interconnection between volcanic eruptions and global systems. As a result of Pinatubo, we saw how far-reaching the effects of a single eruption could be, even affecting weather patterns in distant countries. Drawing from this, What can modern societies learn? Preparedness, as seen after the learnings from the past, is critical. From legislative measures to community drills, history underscores the importance of having robust systems in place to protect lives and infrastructure. The Philippines has implemented extensive monitoring systems for its many volcanoes, which has improved evacuation responses in high-risk areas. But not all historical eruptions ended in success stories. In 1902, the eruption of Mont Pelee in Martinique destroyed the town of Saint-Pierre, killing nearly 30,000 people. The warnings of seismic activity and volcanic gases were largely ignored, illustrating how crucial it is to heed signs from nature. This tragic event serves as a reminder that even in the present day, neglecting the early warning signs of volcanic activity could have dire consequences. Thus, by looking back at these catastrophic eruptions, we can glean insights that improve our understanding of volcanic behavior and preparedness strategies. Could these historical lessons prevent future tragedies? And as we consider the future, we must recognize that complacency can be a civilization's greatest downfall. In our next chapter, we will examine technological advancements and how they can be utilized to predict and mitigate volcanic threats. As we hurtle deeper into the 21st century, technology has become an indispensable ally in understanding and monitoring volcanic activity. From satellite imagery to ground-based sensors, new innovations are paving the way to better predict eruptions and minimize human impact. One of the most significant breakthroughs has been the use of remote sensing. Satellites equipped with high-resolution cameras and infrared sensors can detect subtle changes in a volcano's surface temperature, allowing scientists to monitor activity remotely. The European Space Agency's Sentinel-1 satellites, for example, provide invaluable data on ground deformation caused by magma movement beneath the Earth's crust. This technology allows for real-time monitoring, providing critical information that can lead to early warnings for communities at risk. Another groundbreaking innovation is the use of drones. Drones can be deployed for aerial surveys of active volcanoes, capturing high-definition images and gas emissions data without putting human lives at risk. In 2018, researchers used drones to study the Kilauea volcano in Hawaii, which revealed important insights into lava flow patterns and volcanic gases, significantly improving our understanding of the eruption dynamics. Moreover, advanced modeling and simulation technologies are allowing researchers to simulate volcanic eruptions and their potential impacts. By combining data from seismic activity, gas emissions, and thermal imaging, scientists can create models to forecast eruption scenarios, contributing to preparedness strategies for local communities. However, it's essential to remember that while technology can provide vital information, it is not infallible. The 2014 eruption of Holuhraun in Iceland provided a classic example of how unpredictable volcanic behavior can be. Despite sophisticated monitoring, scientists were caught off guard by the intensity of the eruption and the scale of the lava flows, reminding us that nature can still surprise even the most advanced systems. Despite these challenges, the advancements in technology give us hope. The integration of community-based monitoring, where locals are trained to observe and report signs of volcanic activity, can enhance early warning systems. This collaborative model could be the key to safeguarding lives and improving evacuation strategies in high-risk areas. As we continue to innovate and deepen our understanding of volcanic systems, we hold the potential for a future where the threats of these natural giants can be significantly mitigated. However, as we develop these technologies, we must also ask ourselves, are we prepared to make the necessary investments in safety and education? Up next, we will discuss how society can adapt to the constant threat of volcanic disasters and what resilience looks like in the face of potential devastation. In a world where the threat of volcanic eruptions looms large, fostering resilience within communities is not just important, it's essential for survival. How can societies prepare to face the potential devastation caused by these natural disasters? Resilience begins with education, preparedness, and a robust response framework. Countries like Japan provide an excellent model for resilience in volcanic regions. With over 100 active volcanoes, Japan has developed comprehensive disaster preparedness programs that begin in schools, where students learn about volcanoes and emergency procedures. Regular evacuation drills are conducted to ensure that communities know how to respond effectively when disaster strikes. The Great East Japan earthquake in 2011 showcased the importance of preparedness as communities successfully evacuated in anticipation of tsunamis and aftershocks. In addition to education, establishing clear communication channels with local authorities is critical. Communities must know how to access information about volcanic activity and warnings. In Hawaii, for instance, the U.S. Geological Survey works with local agencies to provide timely updates on volcanic activity, ensuring residents are informed and ready to act. This collaboration between scientists and communities fosters trust and empowers individuals to take action in emergencies. But preparedness is only half the battle. Post-disaster recovery also plays a crucial role in building resilience. After the 1980 Mount St. Helens eruption, communities worked tirelessly to rebuild and adapt, learning from the past to create more resilient infrastructures. Implementing land use planning based on volcanic hazard assessments can lead to safer communities. Moreover, innovative insurance solutions can help communities rebuild faster after disasters. Countries like Chile have developed earthquake and volcanic eruption insurance policies that provide financial support to residents after devastating eruptions. This economic safety net encourages communities to rebuild rather than abandon their homes and history. Resilience is a multifaceted approach that requires collaboration, education, and planning. But as we build our defenses against volcanic threats, we need to confront a pressing question: are we truly prepared for the worst-case scenario? Coming up next, we will dive into the ultimate question: can humanity coexist with these powerful natural giants, or are we destined to face destruction from their wrath? As we wrap up our exploration of the volcanoes that could end civilization, we are left with an essential question: can humanity coexist with these titanic forces of nature? While the threat of a catastrophic eruption always looms, the relationship between volcanoes and humanity is complex and multifaceted. For many cultures, volcanoes are revered as sacred entities, woven into the fabric of mythology and tradition. In places like Indonesia and Japan, volcanic landscapes shape not just the geography but also the identities of communities. Local traditions often include rituals intended to appease the volcanic spirits, reflecting a profound respect for the power of these natural giants. However, this respect must be balanced with the acceptance of scientific realities. The need for a pragmatic approach is evident. Governments and communities must invest in volcanic research, incorporating scientific findings into land use policies and development planning. By acknowledging the risks and preparing accordingly, societies can build a sustainable coexistence with volcanoes, utilizing their resources while mitigating potential catastrophic effects. In some regions, volcanic activity has created fertile soils that sustain agriculture and attract tourism, proving that volcanoes can offer benefits despite their risks. The beauty of volcanic landscapes draws millions of visitors each year, contributing substantially to local economies. This relationship suggests that while volcanoes can endanger lives, they can also provide critical resources that sustain civilization. Ultimately, the question of coexistence is about finding a balance between risk and opportunity. As climate change alters landscapes and challenges the stability of our ecosystems, we must remember that our world is inherently volatile. By fostering resilience, embracing technological advancements, and promoting education about volcanic systems, we can navigate the challenges ahead. As we conclude our journey through the world of volcanoes, Let us remember that understanding and preparation are our greatest allies in facing these formidable natural forces. Awareness of their power can serve not only as a warning but also as a call to action. Together, we can cultivate a future where humanity thrives alongside these majestic giants, ensuring that the next generation inherits a safer, more resilient world. Let us honor the power of volcanoes while respecting their potential to affect our civilization profoundly. For as daunting as the threat may be, through science, education, and community resilience, we can coexist with the forces that shape our planet. Imagine a volcanic eruption so powerful that it could reshape the climate of the entire planet. Supereruptions are rare, but their consequences are catastrophic. One of the most studied supervolcanoes is the Yellowstone caldera in the United States. This massive volcanic system is not just a national park, it's a potential ticking time bomb. Historical records indicate that Yellowstone has erupted 3 significant times, approximately 2.1 million, 1.3 million, and 640,000 years ago. Each eruption released thousands of cubic kilometers of material, blanketing large areas in ash and drastically altering the environment. Recent studies suggest that Yellowstone is currently in a state of unrest, with increased geothermal activity and earthquake swarms, raising concerns among scientists. In 2021 alone, there were over 2,000 small earthquakes recorded in the vicinity of the caldera. Such activity signals that the magma beneath Yellowstone is moving, increasing the possibility of a future eruption. If a supereruption were to occur today, scientists estimate that it would emit over 1,000 cubic kilometers of ash into the atmosphere, creating a volcanic winter that could lead to widespread crop failures and food shortages. But Yellowstone isn't the only supervolcano that poses a threat. The Toba supervolcano in Indonesia erupted around 74,000 years ago, producing what is known as the Toba catastrophe theory. This event is believed to have caused a dramatic drop in human populations worldwide due to climate change and volcanic winter. The ash from Toba spread far and wide, impacting climates as far away as Africa. Studies suggest that such climatic repercussions could happen again. Today, Toba remains an active volcano, and scientists continue to monitor its activity closely. Additionally, the Campi Flegrei caldera in Italy is another site of concern, with significant geological activity suggesting it could erupt in a supereruption scenario. Historical data shows that it erupted dramatically around 39,000 years ago, leading to severe environmental changes. Modern-day residents live in close proximity to this caldera, unaware of its potential destructive power. The world's understanding of supervolcanoes is still developing, and while we may not predict the precise moment of an eruption, ongoing research is crucial. This knowledge could be essential in preparing for the worst-case scenario. The reality is that understanding supervolcanoes is not just about studying the past, it's about safeguarding our future. How can we prepare for such catastrophic events, and what measures need to be in place? The answers may hold the key to our survival against nature's most formidable forces. The story of supervolcanoes reminds us that we live on a dynamic planet, and vigilance is not just recommended, it is essential. Across cultures and through the ages, volcanic eruptions have not only shaped landscapes but also influenced folklore, mythology, and civilization itself. The violent and unpredictable nature of volcanoes has inspired countless myths and stories, reflecting humanity's struggle to understand and cope with these natural phenomena. In ancient Greece, the island of Santorini was home to one of history's most significant eruptions, the Minoan eruption, around 1600 BCE. This eruption devastated the island, leading to the decline of the Minoan civilization. Today, this event is thought to have inspired myths related to Atlantis, stories of an advanced civilization that fell to ruin. The eruption must have struck terror in the hearts of the people, leading them to divine interpretations of the disaster. Throughout history, numerous cultures have attributed volcanic eruptions to the actions of gods or supernatural forces. In Japan, Mount Fuji, an iconic and sacred site, is woven into the fabric of Shinto beliefs. Legend tells of its creation by the goddess Kano Hanasakuyaheim, emphasizing the reverence for volcanoes in Japanese culture. Whenever Mount Fuji erupts, it is often framed within the context of divine wrath or cosmic shifts, demonstrating how deeply these geological events are intertwined with cultural identity. The response to an eruption often mirrors the beliefs and resilience of a community. Similarly, in Hawaiian culture, Pele, the goddess of fire, lightning, wind, and volcanoes, stands central to the narrative of Kilauea's eruptions. The local population views each eruption as a manifestation of Pele's presence and emotions, leading to a profound connection with the land and its changes. This perspective shapes how the community prepares for eruptions, emphasizing adaptation rather than fear. There is also a darker side to these cultural stories. In some regions, volcanoes have been associated with sacrifice, suggesting a grim reality where communities believe that appeasing the gods might be necessary to prevent disaster. Historical records from the Andes tell us about the Inca civilization's practices of human sacrifice aimed at placating their volcanic deities. These sacrifices illustrate the lengths to which communities would go, rooted in fear and the desire for survival. As societies evolve, so do their narratives surrounding volcanoes. Modern science has contributed to the shift from myth to understanding, allowing communities to view eruptions through a lens of knowledge rather than solely mythological interpretations. Educational initiatives are now vital in areas prone to volcanic activity. Schools teach children about volcano safety and mitigation strategies, bridging the gap between ancient beliefs and scientific understanding. Yet, the emotional and cultural connections persist. How can modern communities balance respect for tradition while embracing scientific advancements to prepare for potential disasters? This interplay between culture and science forms a fascinating tapestry of humanity's relationship with one of nature's most powerful forces, reminding us of our vulnerability and resilience in the face of the unknown. In our rapidly changing world, preparedness for natural disasters has never been more critical, especially as we face the specter of volcanic eruptions that could alter life as we know it. Communities located near active volcanoes are often at the forefront of developing strategies for resilience and recovery. The question arises, how do we prepare for the unthinkable? One of the foremost examples is the island nation of Iceland, which lies directly on the mid-Atlantic ridge, making it one of the most volcanically active areas on the planet. The 2010 eruption of Eyjafjallajökull serves as a case study in volcanic resilience. While it caused major disruptions in air travel across Europe, the Icelandic government's preparedness and response were commendable. Early warning systems and established evacuation plans were crucial in saving lives. After the eruption, the community rallied together in the face of adversity, demonstrating a profound capacity for resilience. Economic diversification also plays a part. Iceland has successfully blended its geological wonders with tourism, fostering a sense of community pride and economic stability. This model illustrates how communities can harness volcanic activity for economic and cultural benefits while remaining vigilant to natural risks. In contrast, many regions worldwide lack such preparedness. The 1985 Nevado del Ruiz eruption in Colombia tells a tragic story. The eruption killed over 23,000 people due to a lack of proper warning and emergency planning. Armero, a town located below the volcano, was caught unprepared for the lahar, a mudflow created by volcanic ash and melting ice. This disaster serves as a stark reminder of the consequences of negligence and the importance of implementing comprehensive disaster relief plans in vulnerable areas. The establishment of the Volcanic Disaster Assistance Program, VDAP, by the U.S. Geological Survey highlights proactive approaches to volcanic monitoring and community preparedness. This program supports countries worldwide in developing capacity for better early warning systems, risk assessment, and emergency response. However, as we look toward the future, the looming threat of mega eruptions forces us to consider global collaboration. Such events could have planetary-wide repercussions, transcending borders and requiring coordinated international responses. This calls into question how prepared are we as a global community. Enhancing resilience not only involves infrastructure but also fostering community spirit. Education, engagement, and awareness are vital in ensuring that communities are connected to one another and to their surrounding environment. As the Earth continues to change, the story of volcanic resilience serves as both a cautionary tale and a source of inspiration, urging us to take proactive measures before it's too late. After all, the very survival of civilizations may depend on how well we prepare for the unthinkable. When we think of volcanic eruptions, we often envision the explosive bursts of lava and ash that encapsulate our imagination. But there exists a category of eruptions that goes beyond the ordinary, a category that could redefine our planet's history. These are the supereruptions. First, let's explore what constitutes a supereruption. Simply put, it is an eruption that ejects more than 1,000 cubic kilometers of material. This is orders of magnitude larger than a typical volcanic event. To provide context, Mount St. Helens, which famously erupted in 1980, expelled around 1 cubic kilometer of material. In contrast, the supereruption of Yellowstone, one of the most dangerous volcanoes on Earth, could be hundreds of times more powerful. The last significant supereruption in Yellowstone occurred approximately 640,000 years ago. Much of the United States would have felt its effects, and even the Earth's climate would have been altered drastically. Imagine a world where crops fail, global temperatures drop, and food shortages abound due to volcanic winter caused by ash clouds blocking sunlight. This scenario isn't just hypothetical, it's a grim possibility that scientists study closely. The ash from such an eruption would travel thousands of miles, blanketing cities and towns, causing disruptions in air travel, and leading to the collapse of infrastructures. The potential consequences of a supereruption could be catastrophic for civilization as we know it. Throughout history, there have been warnings and signs that such eruptions are not just remnants of the past but threats looming on the horizon. To explore this further, we turn to the ancient history of the Toba supereruption that occurred around 74,000 years ago in present-day Indonesia. This eruption was so massive that it is believed to have caused a volcanic winter that lasted for years, plunging global temperatures significantly. Some researchers even suggest that it may have reduced the human population to a mere fraction of what it was at that time, possibly leading to a genetic bottleneck in early human evolution. Now, let's delve deeper into the objectives of modern volcanology as it pertains to understanding these colossal forces of nature. Scientists are tirelessly studying supervolcanoes like Yellowstone and Toba, attempting to identify signs of unrest, which include ground deformation, increased seismic activity, and gas emissions. For instance, Yellowstone is monitored using a network of more than 30 seismometers, GPS stations, and gas sensors, all contributing to a comprehensive view of underground activity. But we must also ask, what would happen if we could predict a supereruption? Would we be able to evacuate millions of people in time? Could we develop contingencies for food shortages and global climate impacts? The truth is, even with the best technology, the answer is not straightforward. Even a few days of warning might not be enough. The logistics of evacuating large populations would be monumental. As we ponder this tumultuous scenario, let us imagine the moment when the earth trembles and a roar echoes through the valleys. This is the birth of a supereruption, an event that can shift the course of human history. The emotional and environmental aftermath could take decades, if not centuries, to recover from. So, what can we learn from this? The history of supereruptions provides not just warnings but also insights into the resilience of life. Life has a way of bouncing back, but humanity's presence in the world today makes it all the more urgent to understand these mighty forces. As we navigate the unpredictable nature of these supervolcanoes, one question remains: are we prepared for a world reshaped by the fury of a supereruption? That answer may well define the future of civilization itself. Throughout history, volcanic eruptions have not only shaped landscapes but also cultures and societies. These monumental forces of nature have been interpreted through the lens of mythology, religion, and art, influencing how communities respond to and understand such disasters. In many ancient civilizations, volcanoes were seen as the powerful abodes of deities. The Romans revered Vulcan, the god of fire, who was believed to forge thunderbolts and produce volcanic eruptions. When Mount Vesuvius erupted in 79 AD, burying the cities of Pompeii and Herculaneum, it was interpreted as a divine punishment for human folly. The volcanic ash preserved these cities, offering a glimpse into the lives of Romans, but at a devastating cost. This eruption was not just a geological event, it became a turning point in the cultural memory of the Romans, reshaping their collective identity and religious beliefs. In many cultures, the response to volcanic eruptions can often be traced back to deep-seated myths that provide explanations for these powerful and destructive events. In Hawaii, the volcano goddess Pele is central to cultural understanding. Her eruptions are seen as expressions of her emotions, reflecting the islanders' connection to the land. This deep-seated reverence helps communities cope with the destruction, framing it as a natural part of life rather than a mere random disaster. Similarly, in Indonesia, the eruption of Mount Merapi is often linked to local traditions and rituals intended to appease the spirits. This cultural response can create a sense of community cohesion in the face of impending disaster. While some myths serve a psychological purpose, providing comfort and understanding, the realities of volcanic eruptions often challenge these narratives. For example, as the technology for monitoring volcanoes improves, we have come to learn that many of the traditional beliefs surrounding eruptions may not reflect the scientific realities. This brings about a conflict between modern science and traditional beliefs. The challenge lies in bridging this gap and ensuring that communities are prepared for eruptions while maintaining respect for their cultural narratives. A poignant example is the 2010 eruption of Eyjafjallajökull in Iceland, which not only disrupted air travel but also sparked discussions about the relationship between modernity and ancient beliefs. Icelanders have long had their own folklore around volcanoes, which was challenged by the inescapable scientific reality of the ash clouds. This illustrates the continuing evolution of cultural responses in the face of natural disasters. It brings us to a profound conclusion, that our understanding of volcanoes is a tapestry woven from the threads of science and myth. Recognizing the importance of these cultural narratives alongside scientific insights can enhance our preparedness and resilience in the face of volcanic threats. So, as we reflect on the past and present, we must ask ourselves, how can we honor these narratives while embracing the science that holds the key to our survival? This is a question that underpins our relationship with nature and, indeed, with each other. As we delve into volcanic resilience, we must acknowledge the unpredictable nature of volcanoes. While modern science has made strides in understanding and monitoring volcanic activity, the question remains, how prepared are we for a major eruption? The answer is multifaceted and deeply collaborative, spanning science, government policy, and community engagement. To start, let's look at the lessons we've learned from catastrophic eruptions in history. The 1985 eruption of Nevado del Ruiz in Colombia is a stark reminder. This event claimed the lives of over 23,000 people due to a lack of timely evacuation and poor communication between the scientific community and government authorities. Learning from these mistakes, numerous nations now focus on developing early warning systems and evacuation plans. For instance, in Japan, a country intimately familiar with the threats posed by both earthquakes and volcanoes, intricate monitoring systems have been developed, integrating technologies like satellite monitoring and community reports. Citizens are educated on evacuation routes, and regular drills are held to ensure that responses to eruptions are swift and organized, minimizing the loss of life. Community engagement plays a vital role in this preparedness. In volcanic regions, local populations often have valuable traditional knowledge that can complement scientific predictions. Empowering communities to participate in planning and response builds resilience. This leads to an environment where people feel connected to their safety measures, making them more likely to respond effectively when time is of the essence. Furthermore, governments can leverage technology to enhance communication. Social media platforms, mobile apps, and real-time alerts can be utilized to disseminate critical information during an eruption. For example, during the 2014 eruption of Mount Sinabung in Indonesia, timely notifications allowed for effective evacuations and minimized panic. Such technological innovations in emergency response highlight the importance of adaptability and preparedness in the face of unpredictable natural disasters. However, even as we build resilience, we must also consider the psychological toll that volcanoes can take on a community. The constant threat of eruptive activity can lead to anxiety and stress, which must be addressed in recovery plans. Mental health support and accessible resources can enable communities to cope and thrive despite living in a high-risk area. Preparing for the unthinkable is not solely about protection from eruptions. It's about creating systems that foster resilience, adaptability, and community cohesion. As we look toward the future, we must ask ourselves, how can we create a world where societies not only survive but thrive in the face of such formidable forces? This question challenges us to think critically about our relationship with nature and our collective ability to foster resilience. Imagine a single eruption that changes the course of history. Around 74,000 years ago, Mount Toba on the Indonesian island of Sumatra erupted in what is now considered one of the most catastrophic events in Earth's recorded history. This supereruption expelled more than 2,800 cubic kilometers of volcanic material, leading to a volcanic winter that drastically altered the planet's climate. Studies suggest that this period of global cooling wiped out a significant portion of human life, plunging our ancestors into a survival struggle. It's estimated that the population of Homo sapiens might have dwindled to as few as 10,000 individuals. This cataclysmic event wasn't just a local tragedy, it had repercussions that reverberated across continents. The ash fall affected agriculture, and the subsequent climate changes led to food shortages that laid the groundwork for a significant population collapse. By investigating genetic evidence, scientists can trace modern human lineage back to this bottleneck. The Toba eruption serves as a haunting reminder of how a single volcanic event can threaten the very fabric of civilization. Today, we're faced with the reality that similar supereruptions could happen again, leaving us to ponder, are we prepared for such an eventuality? As we delve deeper into the effects of ancient eruptions, we will explore how they not only shaped our planet but also our very existence, and what lessons we can glean from these monumental events. In the minds of some scientists, the legacy of Toba is critical. It urges us to take volcanic activity seriously as we map out the potential threats that lie ahead, especially among the world's most dangerous volcanoes. But Toba is just one chapter in a long story of catastrophic eruptions. Join us as we navigate through the tales of destruction and resilience that ultimately define our relationship with volcanoes. Volcanology has made significant strides, yet many mysteries around volcanic behavior remain largely unsolved. One of the major challenges is predicting eruptions accurately. The 1980 eruption of Mount St. Helens in Washington state shocked the world, as researchers had not fully grasped the volcano's dynamics until it was too late. The signs were there: small earthquakes, steam eruptions, and ground deformation. But it took years for scientists to connect these dots and prepare for the disaster. The subsequent explosion claimed 57 lives and demonstrated that even with advancements, our predictive models have limitations. This gap in knowledge extends to numerous volcanoes categorized as sleeping giants. Take the Long Valley caldera in California, for instance. It has erupted in the past and could erupt again, but without definitive signals, it remains a mystery wrapped in uncertainty. Risk assessment becomes a difficult task. Many areas close to these volcanoes are densely populated, leading to a constant tug-of-war between urban development and volcanic safety. With over 1,500 active volcanoes on the planet, understanding their behavior is paramount to mitigating disastrous consequences. While advancements in technology are promising, such as satellite-based monitoring and drones equipped with sensors, challenges remain in how to translate raw data into actionable insights. One significant case study is the volcanic activity in Hawaii, which has offered invaluable data but also serves as a reminder of the unpredictability of magma movements. As we uncover and analyze various case studies, the urgency of understanding volcanic behavior becomes starkly evident. The longer we wait to bridge this knowledge gap, the closer we get to the next unforeseen eruption that could alter our civilization. As we plunge deeper into the realm of volcanic research, what lies on the horizon for volcanology? Today, scientific advancements are paving the way for innovative solutions aimed at understanding and mitigating the impact of volcanic eruptions on civilization. The emergence of AI and machine learning technologies holds promise. Researchers are leveraging these tools to analyze vast amounts of volcanic data, looking for patterns that human analysts might miss. Take, for example, the ongoing research in the East African Rift, where scientists are using AI to predict volcanic activity by analyzing seismic data. Such innovations could revolutionize the early warning systems we currently have. However, challenges abound. Many volcanic regions are in politically unstable areas or have limited funding for research initiatives. The threat of supervolcanoes like Yellowstone in the United States continues to remain in the public eye, yet ongoing funding and support for research are crucial. The last major eruption of Yellowstone occurred around 640,000 years ago, but studies show that the magma reservoir beneath is still active, prompting discussions about the need for continuous monitoring. The collaboration between governments and scientific communities is essential to building resilient systems that can withstand future volcanic threats. On the one hand, the advancements in technology and interdisciplinary approaches present a glimmer of hope, but the challenge lies in ensuring that these advances reach those in peril from volcanic eruptions. Facing a future rife with natural disasters, our ability to adapt and innovate could make the difference between a world altered irreparably by eruptions and one that emerges stronger from its challenges. As we step forward, we must question how we can ensure that our evolving understanding of volcanoes is not just a scientific curiosity but a lifeline for communities worldwide. Imagine a force so powerful that it could change the climate of the entire planet, rendering vast regions uninhabitable. Supervolcanoes represent one of the most terrifying natural phenomena on Earth, capable of erupting with a force that dwarfs typical volcanic eruptions. These behemoths are not just mythical beasts, they are real and exist beneath our feet, often unnoticed until it's too late. A supervolcano is defined by its potential to produce eruptions larger than 1,000 cubic kilometers of material. One of the most well-known supervolcanoes is Yellowstone, located in the United States. Its last major eruption occurred approximately 640,000 years ago, and while you might think that's a long time, geologically, this is just a blink of an eye. When Yellowstone erupts again, it could spew ash over much of North America and change global weather patterns for years. Studies suggest that if a supereruption occurred today, it would likely lead to mass crop failures, food shortages, and potentially billions of fatalities due to ash pollution and climate change. But there are others. The Campi Flegrei supervolcano in Italy has a history of eruptions that reshaped the geography of Europe. The most infamous eruption occurred around 39,000 years ago, resulting in the Large Ignimbrite eruption, which left a significant mark on human history. It is believed that the climatic changes that followed this eruption may have contributed to the development of agriculture, as humans migrated in search of more hospitable environments. Currently, Campi Flegrei shows signs of unrest, including ground deformation and increased seismic activity. Such indicators suggest that we should not dismiss its potential threat lightly. The lesson here is clear: supervolcanoes are ticking time bombs that, once they erupt, will take humanity by surprise, possibly bringing our civilization to its knees. As we delve deeper into the science behind these magnificent yet destructive forces, we realize that understanding them could be key to surviving their next cataclysmic event. The future of volcanology is not just about understanding past eruptions but preparing for the unthinkable. So what can we learn from studying supervolcanoes? History teaches us that ignoring these natural signals could be our downfall. But is humanity doing enough to prepare for such an explosive possibility? As we move forward, the next chapter reveals innovative strategies in monitoring volcanic activity that could save lives and safeguard our civilization against these fiery giants. The Earth's climate is a delicate balance, influenced by countless factors, including volcanic activity. While we often think of greenhouse gases as the primary culprits behind climate change, volcanic eruptions can have equally devastating effects. These natural events can introduce massive amounts of ash and gases into the atmosphere, potentially altering weather patterns for years, even decades. One of the most significant examples is the eruption of Mount Pinatubo in 1991. This eruption is often studied for its profound impact on the global climate. The eruption released approximately 20 million tons of sulfur dioxide into the stratosphere, forming a sulfate aerosol layer that reflected sunlight and lowered global temperatures by almost 0.5 degrees Celsius for about 2 years. This temporary cooling had a ripple effect on global weather, affecting monsoons and agricultural production across various continents. But what does this mean for our future? As the planet continues to warm, anxieties mount that the increasing frequency of climate-related disasters may trigger more volcanic activity. Scientists have noted that some regions experiencing severe climate shifts are also volcanic hotspots, suggesting a potential relationship between climate change and volcanic eruptions. For instance, in Iceland, the melting glaciers have increased volcanic activity beneath the ice cap, leading to more frequent eruptions. Another layer of concern is the possibility that supervolcanoes could erupt in response to global warming. The intense heat from the Earth's surface could compromise the stability of magma chambers beneath supervolcanoes, leading to more eruptions. For example, the geothermal activity at Yellowstone National Park has been monitored closely, especially in light of rising global temperatures. Some scientists warn that we must remain vigilant as the interaction between climatic changes and volcanic forces continues to play out. The consequences of volcanic